Hi, Algebra 2, and welcome to lesson 1.3. We're going to talk about piecewise defined functions. So we're going to graph them. We're going to talk about domain and range. We're going to get right into this. Let's look at our essential question. How do you model a situation in which a function behaves differently over different parts of its domain? So this is what we're going to answer today. It's a pretty big question. We're going to answer it by looking at some piecewise functions, looking at the domains of these things. So let's get going. We will get right into example number 1. We're going to model with a piecewise function. Piecewise defined function. I'll just call it a piecewise function here. So Alani's got a summer job as a lifeguard. She makes $8 for up to 40 hours each week. If she works more than 40 hours, she makes 1.5 hours. Let's see, or she's going to make $12 an hour. That's nice that they did that for us. Over 40 hours. So let's make a graph and write a function that's going to show Alani's weekly earnings based on the number of hours that she works. So let's go ahead and get out a graph and take a look at that. And we've got one sitting right here for us. All right, let's have a look at this. All right, so she's going to make, so we're going to have to go, I think we're going to have to go by tens on this, right? If she's working 40 hours. So this is going to be, our x-axis is going to be hours, or, it's usually time. And then our y-axis we're going to have is going to be pay. How much she's getting paid. All right, Alani, you get $8 an hour for up to 40 hours, right? So if we're going to go, so let's go ahead and I guess if we make these here, I guess if we make these units of 4, well, we're going to need more than that, right? So let's make these all 10. So instead of a 2 there, my bad. Each one is 10. Each one is 10. So that means that this is 20, 40, 60, 80, 100, 20, 40. But we don't have to really worry about this axis because she's not going to lose money. All right. And it looks like, this axis is actually going to have to be in the hundreds. So that's 100, 200, 300, 400, right? All the way up to this right here is going to be up to 1,000. I think that's going to work out for us as far as the units that we're going to choose. So what that means is that at 40, right, the money that she's made is at $320, right? $320, right? If she's worked 40 hours, she's made $320. So I've got a graph that represents, right? I've got a function that represents what she makes when she works up to 40 hours, right? Now, after 40 hours, now she's making 1.5 times her pay. So that's $12 an hour. So then her pay is going to increase at that point much more quickly. For instance, right, once she's worked 50 hours, she's going to be at $440, right? And what I'm going to have to do to that is I have to actually add the 320 plus the 10 times the 12. Let's go ahead and look at where she's at after she's worked 20 hours of overtime. So 20 hours overtime is at 60. So now we're going to be at 560. 560, probably somewhere around there. And if she's worked now 80 hours, so that's going to be 40 hours over her overtime, right? She's going to be at Okay, so we're going to see that we're going to have a bit of a sharper line here. Not a lot, but a bit. So there we go. We have written a function based on, or sorry, we've actually graphed this thing, right? So we made a graph, but how would we write a function that shows Alani's weekly earnings based on the number of hours that she works? Well, it looks like there are two of them, right? The one in the blue and the one in the red. So in the blue, that looks like f of x equals what do we got? It's a slope of 8, right? Y-intercept of 0, so that's going to be 8x. Right, every 8x gives her every 1 hour that we work, we make $8. Okay, so all right. But this is only defined for right. It only goes from the interval from 0, we're including 0, all the way up to 40, right? We got something else going on here, right? With our other function, it looks like we've got some other function. We could call it g of x. Let's put it in the correct color that we've chosen. So it looks like almost like we've got another function that now the slope is 12. But we've got to add to it the money that we made when we worked the 40 hours, right? But this is only, we're only looking at this function on the interval from 40, or from, my bad, not including 40, right? Because it's anything over 40. So from 40 all the way up to, in this case, right, we're going to say that she's only going to work 80 hours a week. She's got a restriction. So all the way up to 80, but we're going to include it. All right, that's what we've graphed right there. And we can actually write this in a different way. We can write this as a piecewise function. All right, but hold on. That doesn't seem right, right? If that was my equation, then I would have a y-intercept of 320. So that would mean that my graph should be crossing right here. So I must have made a mistake. I think that's the way I'm calculating it to get those points, but this is not going to be the function. We got the restrictions on the domain right, but what's going on here? How are we going to do this, right? Okay, how did we calculate this? We took, right, we took our 8 times 40. That's going to be the money that she makes for normal hours, right? And we are going to add it, right? We're going to multiply times 12. But there's something weird going on, and I'll put this back here in a second. And that is that if I just put 12x like I had before, it's going to start us here at 40. What we want to do is take into account that we're only multiplying times 12 for values of x that are greater than 40, right? So if we go ahead and consider this to be 12x minus 40, what's going to happen, right? When x is 40, right, this whole quantity here is going to be 0. And so that's going to make more sense, right? With this particular function, right, at the very beginning, we're going to wind up with with x equals 40, right? We want to start at 40 and go up from there. So that's going to help us out with that. Let's go ahead and simplify this. So we're going to have 320. We're going to distribute this 12. So 12x minus 480. Which is going to give me 12x minus 160. And that makes a lot more sense, right? That if I was to follow this line down, right? If I was to actually follow this down, should be somewhere at negative 160, somewhere around there. So that looks better. I like that. What I was doing before works for calculating each of those points like we were doing, but we've got to think a little bit differently when we're coming up with a function. So, hey, we've got these two, right, that are defined for these certain intervals. Remember, this one had the interval from not including 40, right, all the way up to, in this case, 80, and we included it. We could put these two together. We could define this whole thing as a piecewise function because it doesn't make sense to use two different functions when we're talking about one thing. We're talking about the money that this person made. So instead, we'll write this as a piecewise function, right? So p of x is going to be equal to, we're going to use this fun bracket here. And our first function is going to be 8x. And we're going to say that that's only going to be defined for values from 0, including 0, all the way up to 40, right? So x can be between 0 and 40. But for our other function here, 12x minus 160, which represents what's going on after she has started making overtime, this is only defined for values of x that are strictly greater than 40. And this right here, ladies and gentlemen, is a terrible arrow. No, it's trying to point at a piecewise defined function. I'll try to make it look better. I'm sure that's good use of time. All right. So we've answered the question. Let's go back to our Savas and have a look at where we're at now. So what did we do? We came up with a function and we came up with a graph for this. That's awesome. Let's answer another question. Let's try it. So we're looking at the same thing. How much does she work? How much does she make if she works 37 hours? Guys, you will be just fine doing this. So for the 37 hours, we would have to plug that into this one, right? So we would use the 8x function. So we plug 37 in there. It's going to give us the amount that she made. But if we're going to look at 43 hours, for this 43 hours, we are going to have to plug that into here. Because what? Because x is greater than 40. Awesome. Let's go ahead, move right along to example number 2. So now we're going to graph a piecewise defined function, just like we had there. Let's go ahead and get out our handy dandy smart notebook. Take a look at that. So let's go ahead and graph these. Let's go ahead and first choose some appropriate units here, because if we look at, first graphing the 4x plus 11 here, we're going to notice, and we're going to graph it between -10 and negative 2. So let's real quick just look at the 4x plus 11. Let's look at what happens when x is negative 10. So that's going to be, of course, right, 4 times negative 10 plus 11, or negative 29, right? And how about when x is negative 2? That's the upper boundary of this, so that's going to be 4 times negative 2 plus 11, or 3. So what that means is that this guy is going to go through the points right here. When x is 10, it's going to go through the points negative 10, negative 29. And when x is negative 2, it's going to go through the point negative 2, 3. So that means that over here on my y-axis, right, I've got to go as far as 30. And over here on my x-axis, I only have to go as far as negative 10, right? So I could go up to 10 here and then negative 10 here. So I think that what I'm actually going to do is go ahead and make these units. I'll make my x-axis units of 2. So then that's going to be a negative 2. That's a positive 2 there. And then on my y-axis, since I need to have a little more, I'm going to go with units of 3. So this is negative 3, and that will be positive 3 up there. It's kind of weird to have the units that way. I think it's going to work out. Let's plot these 2 points. So negative 10. Let's do the negative 2, 3. So negative 2, 3 is going to be right there. And a negative 10, 29 is going to be down over here. So we got negative 10. So 2, 4, 6, 8, 10, 12. Oops. 2, 4, 6, 8, 10. And then we'll be at negative 29. So from there, we're going to go to like 1, 2, 3, 4, 5, 6, 7. That takes us to 21. 8 takes us to 25. 9 takes us to 27. So somewhere right there is going to be our other point. Fantastic. So we found the 2 points for this one. I believe it's going to be graphed. Let's go ahead and actually graph it in red. Here we go in red. And it's actually going to go, and it includes negative 10, right? So it includes negative 10. It includes, oh, it does not include negative 2. Sorry about that. The negative 2 is not included. So that's got to be open. It does include x equals negative 10. So there's the first one. All right, let's go ahead and graph the second one, the x squared minus 1, between negative 2 and 2. Okay, well, this one's going to be a little different since it's not a straight line. We're going to have to look at it as a parabola, right, that has been shifted down 1 unit. So we know that it's going to have its 1 unit, so it's going to be, you know, right there. Okay, and what's happening at negative 2? Well, when x is negative 2, y is positive 3. Okay, so it's going to come up here, but it's not being allowed to touch it. And then when x is positive 2, y is going to be positive 3. And now the circle that was open, right, because we have to include the negative 2, even though it wasn't included here, right, in this case. Now it's included, so It's actually going to be included in that second graph there. And this value, x equals 2, is included in this graph, so we'll fill it in. All right, both 2's are filled in. All right, fantastic. So we've got the function x squared minus 1 graphed between -2 and 2. Now let's graph x plus 1 between 2 and 10. So let's do a little math. Let's figure out for this guy, right, for x plus 1, what's going on when x equals 2? So that's just 2 plus 1. So when x equals 2, we have a y-coordinate of 3. So starting right there at 2, 3, where our parabola ended. And then when x is equal to 10, what have we got? We've got the point 10, 11. So let's go ahead and graph that one. Let's do it in green. Okay. So we've got this point at the end of our parabola, and it's included for the parabola, but we'll notice that not included for this one. So we'll start it just at the end there. We have the point 2, 3, we have the point 10, 11. So units of 3, so 3, 6, 9. I don't know, I'd say 11 is maybe right about here. And we're including the value at x equals 10 because we have, right, less than or equal to, that x is less than or equal to that. And there we go. So thus it has been graphed. We graphed this piecewise function. First one, good job everyone, let's keep it going. All right, so going back over to our Sava's Interactive Student Edition. I'm looking at this, and we're being asked for what the domain and range is, and what over what interval the function is increasing and decreasing. So I said we're going to keep it going, but we're not. We're going to go back to this. We got to talk about domain and range, and over what intervals the function is increasing or decreasing. All right. So let's talk about domain. So the domain of f of x. Ooh, we're in green. I don't care. Let's go for it. It's a pretty color. Just pretend that it's a happy green tree. Just lives right over there. Look at it. Just like it's got a colon right after it. It's its neighbor. It's a happy domain. Anyhow, what are possible x values, right? It's gonna stop at -10. But it also is including -10, and then stops at +10, and that point is included. How about our range of f of x, our piecewise defined function? Well, it looks like its lowest value, its lowest y value, and it is an included y value, so I'll use a bracket, was -29. Remember that we calculated that. It goes as low as -21. It goes as high, 29. It goes as high as +11 over there on the other side. So there's our domain and range. Let's talk about what intervals for which this thing is increasing and decreasing. So it is increasing over a couple intervals, right? It's going up on the interval from x equals -10 to -2. And it's increasing from the interval from 0, right? From x equals 0 there at the vertex of our parabola all the way up to 2. Now you'll notice that I've used parentheses and not brackets. And that is because at the point -10, it's not increasing yet, right? So we can't include that. After -10, it begins increasing. So those are going to be parentheses for that reason. How about when it's decreasing? So it's going to be decreasing over the intervals from -2 to 3. And it looks like that's it. And from -2 to 0. It is decreasing. That's it. I think I do need to fix something right here. For the first function, it's increasing from 0 to 2, but then it does just keep on increasing after that. Sorry, so it actually increases all the way up to 10. Sorry about that. I had it stopping there, but you know, it's still increasing, right? Just at a different rate. So it's increasing as it goes, you know, up to the blue here, right? And then, but it just still is increasing, but increasing at a greater rate. So we got to go all the way to 10. Awesome. All right, let's go back to our syllabus and see what we got going on. All right, so we've got some try-its. I'm going to do these with you guys. So encourage you to guys have your interactive student reader out and give this a shot with me. I'm going to go ahead and do this over here. I've got a little file ready for it. Here we go. Let's graph this thing. Man, I am loving that we have some lower values here, because I think that we're not going to have to mess with the units so bad like we did on the last one. That's good news. I think it's kind of a little messy when that happens. So let's go ahead and graph this first one. We're essentially going to look at when x is, so for 2x plus 5, we're looking at when x is -6. When x is -6, right, that's -2 times, or 6 times -2, which is going to be -12. -12 plus 5 is going to be -7. So that's the x coordinate, or sorry, that is the y coordinate. So when x is -6, y is -7. Okay, let's also look at what's happening when x is -2. When x is -2, right, x is -2, y is going to be -4 plus 5, or 1. Let's go ahead and plot those points. Now, we're also going to notice that we're including each of those because of our inequality is including equals as well. So let's go ahead and graph this one in blue. So from -6 to -2, 1, 2, 3, 4, sorry. We're looking at the point -1, 2, 3, 4, 5, 6, 7. All right, and we're going to include that point, so it's going to be filled in. And then we've got a point at -2, 1. Beautiful, and we can connect those. We can call that one graphed. Fantastic. All right, so now let's move on and let's look at the next piece of our piecewise function, which is 2x squared minus 7. We want to know what's happening when x equals -2. At x equals -2, that's -2 times -2. 4 times 2, 8 minus 7 is 1. How about when x is 1? When x is 1, we've got 2 times 1 minus 7, which is 2 minus 7, or -5. So let's go ahead and plot those points in red. All right, so we've got the point -2, 1. It's not going to be included with that, so we're going to make sure not to like touch it, right? We're going to leave it filled in with blue. when we start drawing this. We also have a point at 1, -5, and it's not including that point. So you might be thinking, well, what's going on in between there? I'm not sure. But in order to figure it out, we're gonna have to plug in another value to see what's going on. I would like to know what's this thing doing when x equals 0. Maybe that'll help us out. All right, so when x is 0, y is 7. So -7. So let's go ahead and plot that point. So we're at 0, 1, 2, 3, 4, 5, 6, 7. Okay. So now we know it's a parabola. And it looks like that's our vertex. There we go. So we have that second part of our piecewise function graph. Another thing that you could do to help you figure out what that one looks like, put that in your graphing calculator and you would be able to fill that in as well. I'm kind of doing stuff by hand for you guys because it's the best way to see it in my opinion. All right, -4 minus x. Let's look at this piece. When x is 1, so in other words, we got the point 1, -5. And when x is 3, right, and I'm looking at these values, that's how I'm picking what I'm going to plug in. When x is 3, y is -7. All right, so let's go ahead and graph these points in green. So when x is 1, y is -7, and y is -5, my bad. Are we including it? No. Yes. So it should be included here. So we're going to fill it in there. All right. There we go. And we're also including the point at 3, -7 as well. All right, where are we at? 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So we're including that point. And there we go. All done. We graphed our second piecewise function. Guys, I'm going to give you guys one more example because I think that a few examples are going to help you out here. So let's look at what we've got over here. The next example is this triad. And again, it looks like we're going to have some nice, neat units here. And I think this one's going to actually be a little easier. Actually, guys, I'm gonna call an audible on this one. I'm gonna switch up the play. You guys go ahead and do this triad on your own. I'll send you a little something to check. And we are gonna go ahead and move on to the next question here. So now we're going to be writing a piecewise defined rule from a graph. We're not gonna watch this video. I'm gonna go ahead and work this for you. All right, so we'll take this over to the document we've got made. All right, let's see. What are we going to do? Oh, my goodness. We've got a few different lines. Thank God we just got a bunch of linear functions here, but we'll call our piecewise function, well, let's do it in black. So we're going to call our piecewise function p of x equals, and then we make this fun bracket. And we're going to start this, right? So we're always going to go in this direction as we define these. So we're going to start with this one, right? Okay. This has a y-intercept of -4. And if our units are 2, then it looks like I go up 3 over 1, right? All right, so it looks like we determined that our function in blue has a slope of 3 and a y-intercept of -4. And let's talk about the domain of this one. It goes from -2 in my x, right? Because the coordinate of this point that I pointed out, right? As an x coordinate of -2, right? And then it goes up to here, which we said had an x coordinate of 1, but we can't include the 1. So we're going to say that we have a graph of 3x minus 4 from -2, including -2, all the way up to 1, not including 1. All right, let's look at the red one now. The red one, it looks like it has a slope of, what are we doing? It goes, so it looks like I'm going up 2, over 2, up 2, over 2. So if it's going up 2, over 2, up 2, over 2, that's a slope of 1. So 1x. And if I was to go up 2 over 2, that's the same thing as going over 1, down 1. So this is going to cross our y-axis. It's got a y-intercept at 3. So plus 3. And that is going to be defined from x equals 1, including 1, since the circle is filled in, all the way up to 4. Oops, I forgot my x here. All the way up to 4, and it looks like we're including that 4. All right. And just keep in mind, on this graph that you have from your book, these are not points. This is the domain of each or I guess where it goes from. Kind of interesting that if it is the domain, then this one's not right, because let's go ahead and fix it for them. There we go. Now it looks right, if that's a domain. All right, so 5, 8. What slope does that have? It has no slope, right? In fact, it looks like this is just the equation. X equals, y equals 8. And the way that we're going to write that is we're just going to put an 8 here. That's y equals 8, right? P of x equals 8. And that is defined between 5 and 8. And there it is. That is the rule that defines the piecewise the function in this graph. Okay, so let's look at the try it. I'm going to go ahead and do A for you guys right here real quick. Here we go. So we can call this function f of x equals, we'll put our nice fancy bracket there. And remember, we're going in this direction. So if I look at this, it looks like we're going in units of 2. So this is from, looks like this is 7, right? Beautiful. So we're looking at y equals 7. That's this first segment right here, right? And that is for x values from -5 all the way up to -2. All right, now let's look at this second segment. It looks like it has a y-intercept of -5. And let's look at the slope. It looks like it goes down 1 over 1, down 1 over 1, down 1 over 1. So slope of -1. So that is my function there, and that is between -2. I'm going to write all over this real quick. From x equals -2, including -2, all the way to +3. Sorry about writing over the thing there. My bad. And then the next segment we have looks like it's not including this point at 4. But let's look at the slope. It looks like it's going. It's got an interesting thing happening. Determine the slope. Or should we use 2 points? No, let's just go ahead and count it out. So if this is the point, it looks like it's the point 6.9. It's kind of weird to see with the units. And this actually, let's give you another approach. Let's get the slope. This is the point that has the point 4.5. Let's go ahead and calculate the slope using our slope formula. So that's going to be 9 minus 5 divided by 6 minus 4. So that's going to be 4 over 2 or 2. So this has a slope of 2. If it has a slope of 2, then I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. I have too many dots going on here, guys. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Looks like it's got a y-intercept at -3. So 2x minus 3, and that is going to be for values from x equals 4, not including 4 because that is an open circle all the way up to 5. Sorry, that is looking kind of messy. There you have it. All right, I'll have you guys do the try it letter B on your own. All right, so we're going to skip over example 4, go right into example 5. We're going to graph a step function. So let's go ahead and get out our document and have a look at this. So we got shipping costs of items purchased from an online store. Let's see, it depends on the weight. But essentially, if you ship an item between 0 and 2 pounds, you're going to pay $5. Between 2 and 4 pounds, $8, and so on. So let's look at this, right? So if these are my x's, right, then these must be my y's, right? This is x, that's y. So that means that when x is 0 all the way to 2, y is 5. But we're not including 0 in this case. So let's go from, let's go x equals 5, 1, 2, 3, 4, 5, right? Not including 0. And we're saying that x is 0. When x is 0, y is 5. Also, when x is 2, y is 5, right? So and we're including that one. So there's our little function, right? If you pay any amount, right, between 0 and 2, including 2, sorry, if you'll pay $5 for any weight amount between 0 and 2. So let's look at the next one. We have this 8 right there, right? So we know we're going to be at 8, 5, 6, 7, 8. And I should probably change my units here because I realize that I'm going all the way up to 14. Oh, brother, I keep doing that. Here we go. Let's try that again. How about we go by 2s? But it's nice. It's good to see, someone catch their mistakes. We'll go by 2. So if we're at 5, then we're here, right? And all the way up to 2. I believe we can use units of 1s on the other axis. So let's just go ahead and make our x-axis with units of 2. So all the way up to 2. So there's that one. That's going to be nicer, right? We go to our next point. We're at 8. 1, 2, 3, 4, 5. So right here. And we're not including x equals 2, but we are going up to 4, and we're going to close that. Okay. Our next one, we're at 11. So if this is at 8, we're at 9, 10, 11, right? And we're saying when x equals 4, y is 11. But we're not going to include that point, and we're going up to 6 now. And we're going to not include that. The next one has us at y equals 14. So 11, 12, 13, 14 there, right? And I'm seeing that the 6 is not included. You're seeing that there's a pattern forming, right? So I start to really just kind of go with the pattern, and we go all the way over here to 8. What is the domain of this? The domain is going to be from 0, not including 0. Actually, let's go ahead and use our interval notation. So 0, not including 0, all the way up to 8, but we're going to include 8. Our range. Our y values. Well, we've got y values all the way from 5 to 14, and we're going to include all of those. All right, except that, can we really include them all? What do you think? I think we're just looking at a set of numbers, 5, 8, 11, right? There's no continuity in between them, right? Because there's nothing in between, right? What I had written before includes all that stuff. We can't include it, so what we're going to do for our range now is just include the y values that we have, right? So at y equals 5, we do have, all of this happening here, right? And at y equals 8, we have all of this, but like I said, nothing in between. So we're just going to include those specific points for our range. And our minimum is at 5. We're talking about minimum y value. And our maximum, we're talking about our maximum y value, which turned out to be at 14. There you have it. So I'll go ahead and let you all, please do this, try it here on your own. And for this one, I think that giving it a shot at this point is going to really help you get the hang of it. And so that's all. I just want to talk about our piecewise functions. We can represent these in words. We've represented them using algebra, and then we looked at them in terms of a graph. How about our essential question for the day? How do you model a situation in which a function behaves differently over different parts of its domain? So how do you do that? We explained how you're going to do that today. First, you are going to look at each different part within that part's domain, and then include that in a function that has that brace bracket, right? So we'll include that in that. We'll have each of its different parts and each of its different parts domain, right? That's what they're going to look like. So just a picture of what I was saying. So we'll look at each different part and its domain, and we'll include a model of the function in the brace. Algebra 2, thank you so much for watching today. I hope you have a fantastic day. And if you're not, I really hope it gets better. Take care of yourselves.